All right, this is lesson 7.4, continuing our discussions on logarithmic functions. And actually what we're going to do in the second video is we're going to learn how to write the inverse of logarithmic functions. And I'm going to add one more thing to that. We're actually going to learn how to calculate them. In the last lesson, you learned that, or in the last video, we learned that that the 2, remember, was our base, 3 was our exponent, and then that equaled the number inside. Okay, we did the circle. Remember, we did the circle bin in the last lesson. In this lesson, we're going to actually first of all discuss two types of logs that we have. Now, if you'll remember, first of all, a common log is any log, and this is known as a common log, is any log that has a base 10. So in other words, it's going to look like log base 10 equals x. And the way we're actually going to write that is you're going to write log, and then you're just going to write x. So in other words, if there's not a base on there, the base is going to be 10. Okay, and we can actually evaluate these. Most scientific calculators actually have a button, and so if you look anywhere on there, if you have one of these blue and nice ones, it's actually going to show the log button is actually going to be right underneath the light blue second button. It's kind of located in this area right here. Okay, and so all you have to do, I'm going to go ahead and use the website. We're going to look for log 5. Okay, so let me shrink this down just a tad bit. Okay, so we're going to look for log 5. So if you'll notice, and this one has a lot more functions that we won't need. We will be using some of these functions, but primarily when you're looking for a common log, we're looking for this log button right here. So we just simply click log, and then you're going to type in 5. So log 5, and if you notice when it puts it up here in the upper here, you see that it has a base 10. Okay, hit the equal button, and it'll simply calculate what log base 10 of 5 is. And so log 5 equals approximately 6.99, and we're going to put these to 3 decimal places, so 0.699. Okay. The other type of log is a natural log. Okay, and this is whenever we have a log base e. Okay, so log base e, and the way we're going to write this is an ln. It stands for natural log. Okay, there should be an x in there. Okay, so whenever you see this, you got to automatically think, hey, wait a minute, that's a log base e. Okay, so common logs have a base 10. Common logs have a base 10. Natural logs have a base e. Okay, and the way you evaluate these, it's very much the same way that you would actually calculate a common log. We're going to evaluate 0.1. So instead of looking for, since we're looking for a natural log, you look for the ln button. Okay, and typically the log button and the ln button are real close to each other, like on the blue calculators that I showed you in the corner. The actual ln button is right underneath the common log button. Okay, so right here's our ln button. So let me clear this out. We're looking for our ln button. So you simply just click ln. It shows up right here, and it also show up over on this side. And then we just put in our 0.1, and then hit enter. It may take it a few seconds to go ahead and calculate it, and then you notice that it's negative 2.303. Negative 2.303. Okay, and that's as simple as it is to solve it. So let's look at an example when we'd actually use this in real world. So here's our example number 1, and it says the slope s of a beach is related to the average diameter d in millimeters of the sand particles in the beach by the equation. Now, most of the problems that you're going to actually have an equation. Okay, so the slope of the beach is actually equals 0.15 plus 0.118 log d. Okay, now remember, since I don't have a base down here, that would be a common log. Okay, find the slope of the beach if the average diameter of the sand particles is 0.25 millimeters. Okay, well, this right here is the diameter, so we're just going to simply substitute that in. We'll receive the d. So the slope is what we're looking for. Find the slope. 0.159 plus 0.118 log of 0.25. Okay, and so when you actually put that in the calculator, Scientific calculators are great in that you can actually input all the information into the calculator all at once. So let's go ahead and do that. Okay. So we have 0.1, let's clear this out. 0.159 plus 0.0118, 0.118 log, and then it was 0.25. And it's a good idea to go ahead and close the parenthesis. So when you look up here, this should look the same. And remember, our log was a log base 10, so everything's right. Hit enter. Again, it might take it a few seconds to calculate, but you quickly find that the slope is about 0.087. So 0.087. Okay. So that's how we're going to use logs. Okay. Now part 2 of this is actually calculating. We're going to actually find the inverse of the function. Now, if you remember way back when we calculated the inverses of these, the first thing that you need to do is you need to switch your x and y. Okay, so we're going to switch x and y. So y becomes the x. Everything else is going to stay as it is, and the x becomes the y. Okay. The next thing is you're going to rewrite it. You're going to rewrite the logarithm in exponential form. Okay? And your hint here, remember, is circle bin. Okay? Actually, let's write it like this. Circle bin. B-E-N. Okay? All right. So when we do this, remember we start. Now, just because the equal sign, instead of swinging over this way, we're actually just going to swing this way. Okay, so let me switch colors. So start with our base. So it's going to be 3 to the x equals y. Okay, and the last and final step would just be to solve for y. So make sure that it is y equals, and this one's y equals, so we're done. Okay, all right, so let's go ahead and look at the next example. The next example, again, same thing. Remember, we got to switch x and y. So we're going to have x equals log 2y plus 1. Okay? And then we're going to circle around. We're going to write an exponential form. Okay? So we're going to circle around. It's going to be 2 to the x equals y plus 1. Okay? And then we just solve for y. So in this case, it would just be, we got to subtract 1 on both sides. So 2 to the x minus 1 equals y. Okay? All right. Last couple examples. If I looked at this one, now this one you're going to have to add a step. Okay? So our additional step on this one is, if remember, when it's an ln, this would be a natural log. So you got to change common logs to log base 10. You actually have to write the base in there. Natural logs. Remember, natural logs. Okay, so ln's got to get changed to log base e. Okay, so this one, I'm just going to read y equals log base e of x plus 1. Okay, then the rest of the things is exactly the same. Switch your x and the y. So x equals log base e of y plus 1. The next, circle bin. So e to the x equals y plus 1. And then just solve for y. So minus 1. So e to the x minus 1 equals y. Okay, and you're done. Okay. So let me go ahead and do one more of those examples. This is a natural log again. So remember, when you have natural logs, you have one additional step. And that additional step is you've got to write so it actually has a base e. X minus 3. And then x equals, switch your x and the y. And then you're going to write it. Remember, you got to write it in exponential form. So y equals, oops, let me back up a second. I already switched the x and the y. E to the x equals y minus 3. And this time to get the y by itself, I'm just going to add 3. So e to the x plus 3 equals y. And you're done. Okay. All right. Well, that concludes lesson 7.4. So make sure that you've watched video 1. It should have been a prerequisite for video 2 because there's a lot of information in that first video that you need in order to solve this one, particularly for circle pin. So go ahead and complete some of the practice problems that's attached to the lesson. And then when you feel comfortable, you're doing really well in the practice problems, then go ahead and complete the quick check.